Let's talk about NFTs next, non-fungible tokens. That is, tokens that can only exist once, where there's only one coin in existence. The examples of native tokens that we have studied so far are definitely not NFTs, because we could easily mint as many as we wanted of those. Both in the first example, where minting was totally uncontrolled, but also in the second. As long as you are the owner of the specified public key hash, you can mint as many tokens as you like. Now, in order to produce an NFT, maybe the first naive idea would be to actually, in the policy, look at the forge field, which we haven't done so far. All we did look at in the last example was the signatories of the transaction. But if we actually look at the forge field, we could add a condition to the policy that the forged value has an amount of 1. But that wouldn't help us. That would only mean that during one transaction you can only mint one token. But nobody could stop us from submitting as many of these transactions as we like, and then again mint arbitrarily many tokens. So that won't do. That won't enable us to guarantee that a given token can only exist once. A second option that is actually being used already on the Cardano blockchain, because native tokens are available since Mary, which predates Plutus, is to use deadlines. So we saw in previous examples, in previous lectures, how time can be incorporated into Pluto script. And we can do the same, of course, in policy scripts. So the idea here would be to have a deadline that only allows minting before the deadline has passed. Then if you want to do an NFT, you mint one coin before the deadline has passed and then allow the deadline to pass. And then it's guaranteed that after the deadline, no new tokens will ever be minted. But in order to check that before the deadline you only minted one, you need something like a blockchain explorer. You must check on the blockchain that only one of these tokens was ever minted before the deadline. You're guaranteed that after the deadline, no new ones can be minted, but in order to make sure that only one was minted before the deadline, you actually have to check with the blockchain explorer. So in that sense, the NFTs that are on Cardano right now are not true NFTs in the sense that the currency symbol by itself guarantees that they are NFTs. In order to check that only one exists, you have to look on the blockchain. Now, using Plutus, it's actually possible to mint true NFTs, where if you know the policy script that corresponds to the currency symbol, you can be sure that only one such coin can be in existence without having to resort to something like a blockchain explorer. And if you think about how to do that, you must prevent from there ever being more than one minting transaction for the token in question. So whatever you write in your policy script, it must only result in true for one transaction. And it must be impossible to do the same again in another transaction. And at first that sounds impossible, because why can't you simply do the same transaction again later, and then validation should again succeed and it should be possible to mint token again. At least if you do it in the same slot. I mean, we mentioned deadlines before, so of course time plays a role. But why can't you simply at one slot issue the same transaction several times? And the key here is that we need something that's unique. We need something on the Cardano blockchain that we can refer to in our minting policy that is unique, that can only exist in one transaction and never again. And that is a very important trick, something to keep in mind. And the idea is to use UTXOs, because for the reason how UTXO works, UTXOs can only exist once. Every UTXO is unique. You can never have the same UTXO again. A UTXO is there, and at some point it may be consumed as input to a transaction, and there can never ever be the same UTXO again later in the life of the blockchain. Of course, there could be another UTXO that goes to the same address and has the same value and has the same datum, but that will still not be the same UTXO in the sense it will have a different ID. So what is the ID of a UTXO? Well, a UTXO is the output of a transaction. So in order to pinpoint a specific UTXO, you must pinpoint the transaction it came from via its transaction ID, and you must say which output of that transaction it was. The outputs of a transaction are ordered, so by specifying the transaction that produced it and saying which item it was in the list of outputs, you can uniquely identify an UTXO. And transactions are unique. There can never be the same transaction again. And because transaction and index determine the UTXO, this implies that UTXOs are also unique. So now, of course, you can ask, why are transactions unique? And that is a bit subtle, because they wouldn't be unique necessarily if it wasn't for fees. If it wasn't for fees, you could have a transaction that has 0 inputs and only outputs without value. So transactions with no inputs and outputs where each output doesn't have a value. Such a transaction could exist several times. You could have the exact same transaction and it would have the exact same hash and hence the exact same transaction ID. But in a system with fees like Cardano, you can't have such a transaction because you always need an input that provides the fees to pay the transaction fees for the transaction. And as soon as you have an input, that input must come from somewhere. It must come from a previous UTXO. So basically, by a simple induction argument, you see that as soon as you have fees, transactions can never be repeated. You can never have two identical transactions in the sense that they have the same transaction ID, because they must spend fees, and these fees, because double spending is impossible, must be different UTXOs for different transactions, and the inputs are incorporated into the transaction hash. So if you have two transactions with different inputs, those two transactions also will have different transaction IDs. So that means that every transaction in the history of the blockchain is unique, has a unique ID, and that implies that also every UTXO in the blockchain has a different ID, a different combination of transaction ID and index. And this is a very important fact, and that is a fact that we can use in order to create true NFTs. So the idea here is to name a specific UTXO as parameter to our minting policy. And then in the policy, check that the transaction that does the minting consumes this specific UTXO. And because of what we just said, once a UTXO has been consumed in this transaction, it can never exist again. So there can't be another transaction that consumes the same UTXO. And this strategy guarantees that with a minting policy like that, there can only ever be one transaction that consumes this UTXO. And that is what we want to achieve in order to guarantee that we have a true NFT that can only be minted once. In order to demonstrate the idea, I created a module NFT. And in the make policy function, I now have two parameters, one of type txoutRef, one of type token name. So txoutRef, as the name suggests, references txout, so transaction output, UTXO, and token name will be the token name of the NFT. There would be various other choices. For example, I could turn those two pieces into one parameter. But I also wanted to demonstrate how to have scripts with more than one parameter. So how does it work? So oref is the reference to the output we want to consume in this transaction to make sure that this can only happen once in one transaction. And tn is the token name. Again, we don't use the redeemer, and the context. So we have to check two things: that the UTXO specified by oref is indeed consumed. So that's the first condition here, that I delegate to has UTXO, the helper function. And the second condition is that we indeed only mint the token once, exactly once. So let's look at the helper functions. First, just the txinfo, because I need that in both helper functions in both checks. Now the has UTXO. If we look at the documentation for txinfo again, this is now the first time that we don't just use global field that applies to the transaction as a whole, but have to actually look at the inputs, at individual inputs, because we have to make sure that this transaction, this minting transaction, indeed consumes the specified UTXO. So we will use this txinfo inputs field, which runs a list of type txininfo. And if we check this, we see that txininfo has two fields, and one is called txininfo outref and is indeed of the right type of txoutref. So as you recall, an input consumes an output from a previous transaction, and this specifies which output. So going back to the code, any is a standard Haskell function that checks whether any, that is at least one element of a list, satisfies a condition. So for example, I can check any even 2, 3, 5. That will be true because 2 is even. But if I change that into a 1, it will be false. Okay, so we check that any of these, and this we just looked at, so that is an input of the transaction. So I is now the input, and we use this function we looked at in the documentation just now. So this is now the output reference that this input I consumes, and we check whether this equals the given UTXO. So this line checks whether there's any input that consumes this output. So that's the first condition. And the second condition, we actually look at the txinfo forge field, which tells us which value has been forged. We use the flatten value function I explained earlier, which will turn the nested map of the value into a flat list of triples, currency symbol, token name, amount. And we expect that there's exactly one such triple. So in this transaction, only this one NFT should be forged, nothing else. So in all other cases, if we don't forge anything, or if we forge more than one token, we immediately return true. But if there is exactly one triple, then we want to check that this is the currency symbol is the currency symbol we are currently validating. The token name is the given token name, and the amount should be 1. So now there is a slight chicken and egg problem, because in order to check that the CS, the currency symbol, is the currency symbol we are currently validating, how are we supposed to do that? Because what is this currency symbol we are currently validating? Well, it will be computed from first taking this Haskell function, compiling it to Pluto script, and then taking the hash. That will be the currency symbol. But we are in the process of writing this Haskell function. So how can we possibly inside this function already know what the result of hashing the script, which is compiling this function, will be? And for this purpose, there is a a special function that works on the context, on the script context, and it's called own currency symbol. And this is made for exactly this purpose. So that when we are in the process of checking a minting policy, that we have access to the currency symbol we are currently checking to solve this chicken and egg problem. So this is the currency symbol that this policy is all about. And we check that the value we are forging indeed uses that currency symbol. And we check that it has the right token name, and we check that the amount is exactly 1. However, even though this is very useful in general to have this own currency symbol, in this case it's actually not necessary, because we made sure that there's only exactly one currency symbol in the value that is being forged. Otherwise, we would run into this other case in line 48. So we know we are in the situation where there's exactly one currency symbol being forged. So we know without even looking at it that the policy we are running right now will be for this symbol. So we can actually simplify this and don't even look at it and just skip this condition, because that's automatically true. But only because we are in this special case where we know there's exactly one currency symbol in the forged value. So that completes this function, the make policy function. Now we need to compile it to a policy. So given the two parameters, the txoutref and the token name, we must compute the minting policy by compiling this function. This is more or less as before. The only difference is that now for the first time we have something with two parameters. But that just means we have to apply code twice. So giving this, we have a function with two parameters. We apply the first argument here, the lifted reference to the UTXO. So we are left with a function with one parameter, the token name, and then we apply the lifted token name, and we are left with something of the right type redeemer to script context to bool. So once we have our policy, we can compute the currency symbol also as before. So given the two parameters, we use the policy function we just defined and then get the policy and then can apply a script currency symbol to it. So that concludes the on-chain part, the policy itself. Now in order to try it out, let's write an off-chain code contract that can actually mint an NFT. So let's define a schema with one endpoint mint, which just takes one parameter, the token name. And now we define the contract that mints given the token name. So first we look up our own public key. Now we must find a suitable UTXO that we can consume, that we can pass as parameter to the policy, and that will then be consumed in the minting policy. So we use a function that's available in the contract monad called UTXO_add, and that takes an address. In our case, we are interested in UTXOs that belong to us, that sit in our wallet. And there's a function pub_key_address that takes a public key and then computes the corresponding public key address. So using UTXO_add that address, we now have all UTXOs, list of all UTXOs that are in our wallet. And to keep it simple, I simply take the first one. Maybe there could be some optimization to take one that's large enough to also cover the fees so that we only need one input, but I ignore this. So if there is no UTXO in our wallet, then we can't proceed. So I log an error. If there is one, at least one, I just take the first one, the head of the lists, ignore the rest, and now I can proceed. So this first UTXO that I find in my wallet will be the one I'm using in the policy as a parameter for the NFT. So first I compute the value that I want to forge. So I use the singleton function again. Now I need the currency symbol. For that I have my cur symbol function. And now I have both parameters, the UTXO and the token name. Token name will be the token name and amount will be 1. Now for lookups I need two. First the minting policy, which I provide here, again with these two parameters. And secondly I also need a lookup for the UTXO. So I indicate that I want to use an unspent output or make the algorithm that balances the transaction aware of this unspent output. And I just use all of them. That wouldn't be necessary. It would be enough to just provide this one, the ORFAN, but it doesn't matter to provide more. Finally, the constraints for my transaction. So I want to mint this value well, and I insist that the UTXO I have picked, the first one in my wallet, must be spent. So that can be done with must spend pub key output. Then, as before, I can submit the transaction, wait for confirmation, and log a message. Now the usual thing to define endpoints, where I use the endpoint function and then call the function I just defined, the mid function, then the usual boilerplate for the playground, and finally a simple emulator trace to test this. So as token name I use ABC again, and now I activate the endpoints contract for wallets 1 and 2 with handles H1 and H2, and call the mint endpoint on both of them, on both wallets, and wait for one slot and see what happens. If I reload and run test, I do see that both wallets end up with a token name ABC, but the currency symbol is different. And that is because those two wallets necessarily have to use different UTXOs specified as parameter for the currency symbol, for the policy. So wallet 1 will use the UTXO it finds in his wallet, and wallet 2 will have to find another one in wallet 2's wallet. So both are NFTs, but they are different NFTs because the currency symbols are different. And we also get the expected log messages. So just as a recap, the idea with NFTs, the idea to enforce that only one transaction can mint, is to use a UTXO as input, to insist in the policy, in the minting policy, that the minting transaction uses a specific UTXO as input. And because UTXOs can never exist again, once they have been consumed, the same UTXO will never exist again. This will guarantee that such a transaction can only happen once. And if in addition we enforce that in this transaction that can only happen once, a value of exactly one coin is minted, then we get a policy that guarantees that we have a proper NFT, where there's only one coin in existence.